Welcome to the PhysicsPlace, the place to learn about physics. In this video I'm going to teach you what kinetic energy is and how you can calculate with it. Kinetic energy has something to do with motion. So the energy an object has due to its motion and due to its mass. So if we have a cyclist and he has a certain amount of velocity, for instance 10 meters per second, then he has kinetic energy. And if he will go faster, so if it goes twice as fast, then his kinetic energy will go up. So the amount of motion is important for the kinetic energy. The other thing that's important is the mass. If you have, for instance, this truck, it's a lot heavier. So if it will go with the same velocity as the bicycle, it still will have more kinetic energy because the mass is higher. So the higher the mass, the more kinetic energy. And these two are very important to calculate kinetic energy. To calculate the kinetic energy, we need this equation. We have the kinetic energy, which is measured in joules. We have a half here, which is just the number half, 0.5. We have the mass, which is measured in kilograms. And we have here the velocity. The velocity is in meters per second, and very important, there is a square here. Do not forget it. So this number needs also to be multiplied by itself. Now we immediately have an example. Get a piece of paper, get a pen and a calculator and try to figure this out yourself. A cyclist has a mass of 85 kilograms and a velocity of 25.2 kilometers per hour. Calculate the kinetic energy. So let's see what we have. We have the mass, which is 85 kilograms, and the unit is correct. It is in kilograms. We have the velocity, 25.2 kilometers per hour, and there the unit is not correct. It needs to be meters per second. So we have to divide by 3.6, and then we have 7.0 meters per second. Now we can use this equation. The half is always there, and we have the mass and we have the velocity. So we can put our information in. We have a half multiplied by 85 kilograms multiplied by 7 meters per second, and do not forget the square here, and then we have a kinetic energy of 2083 joules. If it's important to have this in significant numbers, then we have to look at this number, and then it's 2.1 times 1000 joules. If you don't use this, then of course this answer is already correct. If you use this, then you know, and then you should be using it like this. So the kinetic energy is around 2000 joules. Another example, an airplane with a mass of 210 kilograms needs 82 kilojoules to get to takeoff velocity. So before it can take off, it needs a certain velocity, so it needs to go from 0 to this velocity, and you need some energy for it. Calculate the takeoff velocity. Well, we know the energy it needed, we know the mass, so we can calculate the velocity it has then. First, the energy, we got 82 kilojoules, that's 82 multiplied by 1000, or like this, so you can write it either like this or like this with 3 zeros. We have the mass, 210 kilograms, this is already the correct unit, and we have this equation. So this one is the only one which is unknown. So this is how it will look like. 82 multiplied by 1000, because it needs to be in joules, not in kilojoules. The half, of course, multiplied by 210, and the velocity, and of course the square here. Now first we can calculate these two, so it will look like this. Now we would divide both sides by 105, and then we have the velocity square, and that's 780. Now we do the square root, and we know that the velocity is 28 meters per second, because that's the unit. It doesn't specify in what unit the velocity has to be, so this is already correct. Of course, if you want to calculate this to kilometers per hour, then you have to multiply by 3.6, but that isn't given now, so 28 meters per second is correct for now. Another example, a car with a mass of 750 kg needs to accelerate from 28 meters per second to 36 meters per second. Calculate the extra kinetic energy it needs for that. This one is a little bit more difficult. Try if you can figure it out yourself. I will now give the answer. We have the mass, 750 kilograms, which is already the correct unit. We have the initial velocity, which is 28 meters per second, and we have the final velocity, which is 36 meters per second. This is the equation we will use, and we have to use it twice. So first we will use it at the beginning when he has already kinetic energy, because he is already going with a certain motion. So he has already kinetic energy, and he already has 294,000 joules of kinetic energy. Now he will need more energy to go to 36 meters per second, and we have to calculate that again, but then for 36 meters per second. And then he needs an energy of 486,000 joules. And the difference between these two, that's the extra energy he needs. So the difference in kinetic energy, we have 486,000 minus 294,000 joules, and that's 192,000 joules, or you can write it like 1.9 multiplied by 10 to the 5th joules. So either this one or this one is correct. So that's the extra energy it needs. You have to be careful with this one, because if you look at this, you can also think, oh wait, this is 28, he needs to go to 36, so there's 8 meters per second difference, so I will just put in 8 in here, and then you will have a wrong answer. You can try it now, put in 8 here, and it will not be this answer. And it has to do with the fact that it takes far less energy to go from 0 to 10 than to go from 10 to 20. Although the difference is the velocity of 10, still this one will take far more energy, and it has to do with the square here. For example, if we have 0 meters per second and we put 0 here, then it will just be 0. And if we would put 10 there, then it's 100. So it will go from 0 to 100 if we look at this one. Here, if we put 10 in, it will be 100. And if we put 20 in, it will be 400. And you can see that the difference here is a lot bigger. So it will result in a much higher kinetic energy. So to go from 0 to 10, you need three times less energy than to go from 10 to 20. So you have to be very careful that you do never use the difference in velocity, but always the initial velocity and the final velocity. So it will look like this. If you want to have it in an equation, we have the final velocity, and of course the square, never forget the square, minus the initial velocity in the square, and that we can multiply with the mass and with a half to get the difference in kinetic energy. That's it. You should now know what kinetic energy is and how you can calculate with it. If you found this video helpful, please let me know by liking and of course subscribe for more videos. Thanks for watching.